Today, we're going to find the x values of the critical points for two functions. The first function is f of x equals x to the 2/3 power. The second function is f of x equals the quantity x squared minus 1 divided by the quantity x squared minus 4. Let's start with the first one. For f of x equals x to the 2/3, we begin by taking the derivative. The derivative of x to the 2/3 is 2/3 times x to the negative 1/3. That means f prime of x equals 2/3 times the cube root of x. Now, we look for where the derivative equals 0, or where it does not exist. The numerator is a constant, 2, so the derivative will never be 0. However, the denominator has a cube root of x, so at x equals 0, the derivative is undefined. But the function itself is defined at 0 because 0 to the 2/3 power equals 0. That means x equals 0 is a critical point, since the derivative is undefined there, but the function exists. Now let's move to the second function. We have f of x equals the quantity x squared minus 1 over the quantity x squared minus 4. Before differentiating, we check the domain. The denominator, x squared minus 4, equals 0 when x equals 2, or negative 2. So the function is not defined at x equals 2 or negative 2. We'll keep that in mind. Next, let's find the derivative. Using the quotient rule, f prime of x equals the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, all divided by the denominator squared. Simplifying, we get f prime of x equals negative 6x, divided by the quantity x squared minus 4, all squared. Now we find where the derivative equals 0, or is undefined. The numerator, negative 6x, equals 0 when x equals 0. The denominator is 0 when x equals 2, or negative 2, but the original function is also undefined there. Therefore, the only critical point occurs when x equals 0. Finally, let's summarize our results. For the first function, f of x equals x to the 2/3. The critical point is at x equals 0. For the second function, f of x equals the quantity x squared minus 1 over x squared minus 4. The critical point is also at x equals 0. Before we finish, let's review what a critical point means. A critical point of a function is any x value in the domain of the function, where the derivative equals 0, or where the derivative does not exist. But remember, the point must be part of the domain. If the function itself is undefined at that value, it cannot be considered a critical point. So again, derivative equals 0, or derivative undefined. But the function must exist at that x value. That's the key idea behind finding critical points.